Hi everyone, welcome to our webinar. My name is Erin Heffron and I'm a product specialist with IVS 3D. Today's webinar is going to be Fledermaus version 7.3 update, improved workflow with integrated cross-application projects. Today's presenter is going to be Lindsay G. He was our general manager of IVS 3D and he's transitioning to a product manager, product management role for the Fledermaus software with our merger with QPS. Also as panelists you have Mark Payton, who was CTO of IVS. I'm not sure, Mark, what your new role will be. And me, Erin Heffron, still a product specialist. All right, so finally, webinar requests, comments, and ideas can come to me, eheffron@ivs3d.com, or you can reply to that GoToWebinar email, which I think is the email that generates a lot of your emails and stuff that you get about the webinars. If you have questions about Fledermaus or you want to request an evaluation, you can go to info@ivs3d.com. And if you're a client and you have questions, feature requests, bugs, you need help, any kind of client support, please email support@ivs3d.com.
Okay, I'm here. I just undid my mute button and you should be seeing my screen now. Is that okay?
We do see your screen. I'm going to mute myself and I will just unmute myself if I think you're having any problems.
Okay, let me go into the presentation mode here. Okay. Well, thanks very much, Erin, and yeah, welcome to today's webinar. As Erin said, this is not going to be a one-hour webinar. It's really just a short summer webinar. We've found that we can announce different features as the software evolves, but we think this is a better way just to be able to announce a feature and then try and give you some background on how we see this working. So the summary of the webinar, I'm just going to give you an overview of the project framework and how that's evolved from when that was initially released as part of version 7, and describe how that's similar and different between three of the primary data preparation applications. That's DMagic, the new FM geocoded toolbox, FMGT, and FMMidwater. After I've just done a very brief PowerPoint describing some of those, I'll do a quick demonstration showing that across those applications and then the products from the preparation in Fledermaus. And I'm going to use some data that's from Kongsberg EM3002 on some fish trap data that's off the coast here, Isle of Shoals, that were gathered by Centre for Coastal Ocean Mapping at UNH in about, I think, 2004, 2005. The initial project framework was released with our version 7 a couple of years ago, and this really came from our clients' requests. They wanted a more consistent and structured file format before those that have used Fledermaus, and you still can if you just use Fledermaus. You want to import a file and visualize it quickly. It is unstructured. You can still import it, create an SD file, and put that anywhere you want on your file system in your folders. But there was definitely a need with bigger projects, more complicated data, and this is where Fledermaus becomes more powerful when you have data of varying types that you want to integrate together. There was a need for a more structured approach to that. That was included in the updated DMagic, and it was in fact in parallel with that development because DMagic gave that geospatial view of your source data that wasn't there before. So in doing that, it was almost essential to have a structured folder project approach. In that initial stage, one of the other elements that was added, and primarily, was you had to define a project coordinate system for the project. Now, the source data can be different, reproject as you come in and once you're in Fledermaus, but that was one of the main elements that you defined. There was various source data, ungridded, gridded data, images, geotiffs, and those sort of things, and vector data, points, lines, polygons, S57 files, and the like. From that, we created metadata, and then there was also SD files that were generated within DMagic, went into specific areas and folders. So the creation of the projects, let me start with that, is that it was very similar in all applications. It's not identical, but it's almost similar in what you do, whether you start in DMagic, FMGT, or Midwater. As a default, once you've installed the software, depending on the operating system you're running, the project data will be put into the normal places used as whatever your username is, FM data projects. Now that's a default and a preference, and you can change that, but on install, that's where the projects all go. So anytime you open DMagic, FMGT, or Midwater and create a brand new project, it will by default go into that area. There's slight variations with the coordinate systems that you use in each application. DMagic, you can use any of the coordinate system, horizontal coordinate systems we support, so both projected and geographic that are related to the EPSG codes that we fully support within the software. In FMGT currently, I think I might have made a mistake there. I always use UTM and it will automatically project the UTM, but you can in fact use any projected coordinate system within FMGT currently. In FMMidwater, slightly different. It has to be geographic only when you're using the data, the source data coming in, but when you produce the data objects, you can then transform them into whatever coordinate system you need to be when you create the SD files.
Hi, Lindsay.
So
sorry.
Example,
Lindsay?
Sorry.
No,
Yeah.
I know that you're trying, but just really try and speak directly into the microphone. When you turn your head, people are having trouble hearing you.
Okay.
And there might be a slight issue with our connection. It gets a little bit off sometimes, but just do your best. We're using a different kind of interface device, so we will try really hard to keep the audio clear, but if you miss a word or two, I apologize. Go ahead.
Okay, this is the initial screen for a DMagic opening and creating a project, and you'll see the place in here is where the project is going and the coordinate system that's defined. The second one is for FMGT, and you'll see the slight difference here. If you don't define a projected coordinate system, it will auto-compute that into our horizontal UTM coordinate system, and again, this was done by Motor 7. It's going into his default location for the project. And then one for Midwater. Again, this has to be in a geographic coordinate system. Just to show you in a diagram the DMagic folders that are automatically created when you start a project. Under that project name, there's 4 primary folders. There's the, going from the bottom actually is the source data. And this is the ungridded data. Anything that we support in an ungridded data format, that might be a GSF file, ASCII XYZ, any of those ones that you can grid, create a surface, they're in the source data. The output is from DMagic. There's 2 types of output. One is an SD file, so if you create a grid, or anything like that, that goes into the SD directory. If you create the PFM file for editing, that will go into that PFM output subfolder. The next one above is the metadata, and this is created on scan and load of any source data, and that produces a summary for us to quickly access that data, provides bounds, centerline if it's a source ungridded file. And I'll show you that when we get to the demonstration. The ancillary data is related to those other data types that we import into FlaterMouse. That can be grids, images, and vectors, and that those subfolders under ancillary. And if we look at that, I'm running on a Mac today. For those that are not familiar, but it's the same as if you have a Windows Explorer. This is a project I've created in my standard user LG FM data, and under the projects is one webinar projects.fmproj. And so the folders are there, and then there's an XML file that defines the structure of that project and what happens within that. So you can see the metadata source, output, ancillary, and as I say, under that, we'll get to that and show you the subfolders that appear. As I was saying, this is a framework. It's not a structure that gets built exactly the same for every project within every application. So the DMagic structure of folders is the default minimum. But if you have a Midwater project, you can see that the source and metadata ancillary stay the same, but there's more output files. When you use FMMidwater, you're looking at a different aspect of the file. So in this case, we're using a raw.all file, and for the bathymetry, we're looking at the calculated XYZ and other attributes within that raw.all file. When we go to the Midwater project, we're actually not looking at the bottom detect at all, so we're looking at that time series across it. So we need to extract out of the file different information, and that's why there's a slightly different structure within the project framework. One of the things that we do within FMMidwater is we create, for the internal processing, is a generic water column format. So this is taking the packets and integrating all the navigation and the packets together, and it's that's an open format that we have for the processing, and it's available if people want to write directly in that and load the GWC into Midwater. So that's it, and the navigation can be slightly different. Particularly if you use Midwater with, say, an AUV, you might have an independent navigation file because it had to be reprocessed. So there needed to be a directory for that as well. If we go to the geocoded toolbox, FMGT, the project hierarchy is again more complicated because there's, again, using a different section of the file for different type of processing. Now, in this particular case, we're looking at the raw.all, but taking the beat time series out of that file, and you'll see that the output ones are different depending on the type of data we have and what we produce. So if you go down the list at the very top, one of the outputs we produce products is the ARA. So there's a directory for that. Internally, if we combine data, we can convert it into a GSF. There's a directory for that. The geocoded toolbox backscatter files that are part of the intermediate processing during the GT processing, there's a directory for that. Mosaic and navigation again, because it can be slightly different to the bathymetry. So if you look at how this evolves in the folders, you'll see now that when I go into that, after initially doing it in DMagic, additional directories are created by GT, and we end up with those ones, as I mentioned, the ARA, GSF, the statistics as well, GTB, and the navigation folders. So as I was saying, there is a framework for the various folders, but it's different depending on, and you add more depending on which application you're using. So depending on which one you start with, it may have the folders already there. If you started with GT, you have many more than if you started with DMagic. But as I said, the minimum framework is based on the DMagic folders. An example I'm going to run through today, I've pre-built the project, but I'm going through, and this project was built in the order of DMagic, FMGT, and then FMMidwater, and I'll step through those one at a time as we go through. I'll show you what files go into each and how they're different within the different applications. As an example, this is just a couple of screen grabs of the standard DMagic interface with the source data on the left. As you see, I brought in a directory of raw.all files, and this was in a directory called fish traps, and that's why under the ungridded data we're getting that subfolder, and I'll show you that in the other applications. And then I've created a couple of SD files from that. I gridded the data initially just without any cleaning, just the raw.all, and gridded it, and then I also created a QPFN, and that's what you're seeing in the screen to the side. After I've created it in DMagic, as I said, I did that as a base level framework for the project. I then went into GT, and as you step through it, this is a warning that you get, and it says that, you know, Geocoder didn't actually create this project, so it needs to go through and then configure it for its own processing. In this case, I left it at auto compute of the output coordinate systems. I'm on the East Coast here at the Isle of Shoals, and it's a UTM zone 19. So the data was raw.all was WGS84, and then it created UTM zone 19. As you see, if I uncheck that, I can specify the coordinate system I want. But right now I left it as the default. Because it's using different data out of the raw.all file, it also then does another scan of the data, takes that out and creates a coverage. And we'll see what happens with that when I go into the demo. When it loads, you'll see again, same look and feel of the interface. We've got the source data there, has the subfolder because it was brought in through that, but I didn't reload the data. It was there just straight from that other project, and the lines of the navigation are the same, created on in the main graphic geospatial window there. Again, I then stepped in and went to FMMidwater, and again it says, okay, I didn't create this project that you're trying to open, but again, let me know how you want me to configure the coordinate system. And as I said before, for Midwater, you need to have, in a geographic coordinate system, in this case I chose WGS84, which was the coordinate system of the raw.org files that I'm loading. And in that one, the difference again is it needs to extract the coverage, because in this case you're not looking at the snippet, at the beam time series from the backscatter information of the file. You're actually looking at the full water column time series, which was different packets. So again, it creates a separate coverage for that data, specifically for the Midwater type of processing. Again, in the window, same look and feel. We always have the overview of the map view that's now, in this case, on the bottom left. But you'll see for the sensor, there's the fish trap sub folder again. And when it rescanned it for the Midwater and extracted all more information, it gets the details into the sonar, the datagrams that were in that weren't required for Bathy processing within DMagic or at GT for the backscatter processing. But they are required for the Midwater. So more information within the same area and put into the metadata section of the files in the project. So I'm just going to demonstrate that now. I'll get out of here and go to initially DMagic, show you the files, and let me pause there if there's any questions, Erin.
We've had just a few questions, and Mark is addressing them. Mostly, somebody asked, can FMGT accept independent SVP input? And the answer to that is not at this time. We're using the samples from the source file with whatever SVP has already been applied. So that's it.
Okay, so I'll just step briefly through the interface here. This is DMagic. So I think we'll probably touch on other things. This was not going into detail within each of the applications of doing a DMagic, GT, or a Midwater demonstration. This was just to illustrate how, with these sort of data, you can use it within the applications, and by coordinating the projects, it simplifies the workflow. So, if there's questions about the particular application, we have time, but there's other webinars that have been probably done on those that most of the questions I think have answered. So if we look up at the ungridded data here, this was the source data, the raw.org files. We'll see that we've, it was brought in under a directory. When you import, you can import individual files or a directory of files. I brought them in as a directory. And then at this stage, the metadata has been written, and I can view the metadata for that particular file. And for the Bathy processing, in our case, we're looking at the XYZ of the data, and so it provides a simple bounds, the coordinate system, the original data, number of beams, and then what other data was in that Bathy section of the file. If I go across now to the my Finder window, same as a Windows Explorer, this is what I meant. There was all of those files were within this directory, so I just brought in this directory from my data. And this is the structure. Once I built and been through DMagic, GT, and Midwater, this is the structure that ends up in the directory where my project is. And so this is in, if I go back one thing, I have a bunch of different projects here, and I'm in my webinar projects project. You see, as I mentioned, there's the ancillary section where I can bring in grids, images, vectors, which are used by all applications. There's a metadata section, and if we look into that, you'll see the various metadata that was created with DMagic that's for the initial file, and there's a very small SD file of the lines that we're using across all the applications, and then there's the output. From DMagic itself, there's just the two here, which is SD and the PFM files. If I go back to DMagic, you'll see that I've already created some files, and there's the two subfolders, and that corresponds directly into those output directories. So every time out of DMagic you create an SD file from up above, whether it's a grid file or a PFM, it goes specifically within the project. Whereas in FlatorMouse, you can go and put something anywhere you like. This is the structured approach to this. And then normal interface. This is just to illustrate, this is Portsmouth, New Hampshire in the map view up to the top left. Isle of Shoals off the coast, and this survey was done around some fish traps that were out in the just southwest of the Isle of Shoals. And if we turn off the chart there, or make it transparent, we can see here's a very rough grid of the data and the files that this is the navigation files from the source data that came in. Okay, if I now just close out of DMagic, and I'll now start FMGT, one of the nice things that now all of the applications look at is, they'll go back to the last project you are processing. And in this case, it's the same one I had in DMagic. I want to work on that one again, and it just rereads the project and builds the visual here in the scene. And you see I've also built some files here as well, but if we go back to the source files, you'll see it's exactly the same structure as we had before. So we've tried to have the same look and feel across all the applications. So even though you're doing different processing within each, you have the same look and feel across these. In the metadata, it's slightly different because you're using different parts of that file. So we've got the extents again. It has the sonar type, and then also information about right down to the various packets that were within that raw.all file. And you'll see in this case, this one does have water column, and then when we go to the FMMidwater, it's okay to be processed within that application as well. So in this one, source data, instead of having source data and then the panel for the SD files underneath like we used to have or like we do have in DMagic, there's not enough room in this for the other controls we needed to, so we have another tab. And again, these are the SD files that we have within the geocoder processing. So the different outputs we can have are mosaics, we can create statistics, an ARA analysis, and we also have the survey layers, what you're seeing in the area here. It's the bounds of that blue box of the data. So if I look at the mosaic for a little, we've got a number of mosaics. This is the third one. I can see it's a single tile. If I want to turn that one off and look at the previous one, it's actually 4 tiles when I did this one, it's separate tiles. So if you have a long, narrow survey, a very big area, you can now tile within FMGT. So that was that one, and then the first one was just a simple, again, first process of a mosaic. If I turn those off, you've got statistics and normal sort of thing within GT. The various statistics are being created throughout here, and also if I go down to the next one, in ARA, the various ARA characterizations, in this case the classification. We can come back and look at the fee and various elements here, the mean outer values. So as I say, I'm not doing a GT Pro, but just to show you, that's what we see there. And if I now go back to the folder window, you can see within ARA, we've got for that first one, the matching. This is where it goes. Tile 1, all of those various elements. Same with statistics. Down the bottom, we've got the various statistics for that particular tile. And if I go up into, where is that, mosaic, you can see the 3 mosaics that match the GT mosaic panel up the top here. So again, put into exactly that same structure. So easy to find, know where they are, even obviously within the applications, but if you need to find those files later on, you can find those as well. So if I go out of DMagic, GT now and go to Midwater, same again. It knows which project you've been working on. Do you want to open that one again, or do you want to go to another project? In this case, I do want to open the same project again. And let me just open that full screen. So again, we've got the source data here, and you'll see that this is in the same format again, so it's and slightly different structure. We haven't just got a map view now in the main window. The main primary focus is the processing of the water column data, but in this case we have a smaller map view that we can select the data. But the structure here was read exactly from the same structure that we started in DMagic. So again now extend sonar and datagrams, which is the same as GC as well. Now what I was saying, internally when we process the Midwater, we take all those packets that were in the original file, because they're different depending on whether it's a Kongsberg Reason or whatever type of file you start with, and we put it in a consistent manner so it's a integrated PIG structure. And so we do that through converting the sonar data, and what that produces is the generic water column file, which is here. And so again, that provides the information there. And if we go back to the folder layout, that is the GWC files that we're seeing here under fish trap. So here's all the GWC files from this particular project under that same very consistent structure. Again, we don't have space because of the processing we want to do here, so it's not like DMagic with the visual objects, the SD files. It's like GT, so there's another tab, and then there's the file, the objects that we created out of the Midwater tool. So you can do the fans, points, curtains, the normal Midwater processing throughout the data as you move through the various data objects here in there. So all of these are really data preparation tools to get you into DMagic, but they're also analysis tools within each one of those, but whether it be the bathymetry in DMagic, integrating the data, GT for backscatter processing, and Midwater for the integrated view. Now, how do we do that, and how does that all combine? Well, in FlaterMouse, we can bring that together, and now looking in the theme, we have this same overview of where the fish traps are. As I said, this is Portsmouth up to the northwest, Isle of Shoals, and the fish traps down here. We can look at that. And what I've done is, when I brought the data in, for those that didn't realize that, you can actually create parents. This is not done by the project, but I created 3 different parent objects that I can then drag the various SD files under, and you do that under Create. So I created a parent object for each one, renamed it Bathy, Backscatter, and Midwater, and then instead of having all your data just loaded SD files as one long list, you can organize those together and turn them on and off and bring them together like that. So in this case, we've got the chart there. I can make that slightly transparent to see the data underneath, or I can turn it off. And you'll see then I've got the original SD file when I first brought it in and hadn't done any cleaning. We're seeing these objects on the seabed. These are the actual fish traps that are actually midwater, but they were put down onto this part of the seabed because we didn't really know, and that was what the Potom Detect got. But then after I'd run it through a PFM file and cleaned it, we then got a clean cube surface which took out the fish traps from the data. In addition to that, I ran a number of mosaics, and if we turn that on, we'll see we've got a mosaic here. And this one was an export that was actually a geotiff. So you can see this is an export of the mosaic processing as a geotiff. I also had it when I tiled it, I produced a scalar. So in this case, it's not just an XY, it's not just a geotiff, it still has an XY backscatter value that you can adjust the color map for these and then do other processing within the Flater Mouse environment. Drape them on the scene and those sort of things. So if we go from the backscatter, and then additional to that, we also have the midwater, and I can turn that on. And as you know, that's a time-based object. So we're seeing I exported out of those bunch of lines 2 lines in different types of object. Oh, and you can see this was actually, the data was acquired in 2004 by CCOM. And so if we slide along some of these data, we can see that we've now got the point objects, a Kangen curtain and a fan as we go over the fish traps. And if you go back to that pre-clean bathymetry, you'll see that it's all correlated with the backscatter in this scene here. Okay, so let me just go back quickly. One thing I forgot to say, I don't want to say that there. In GT and how we use the data together is one of the issues you might have in backscatter processing, because of, as a good example actually with the fish traps, is that we see that there's the fish traps actually affect some of the processing of the, turn the source data off here for a minute. You can see the fish traps are affecting some of the backscatter processing because all of the pings have been used. So what we can do is within GT is we can say, okay, well, I've already done the bathymetry processing when I ran cube and I edited then the soundings out of that, so I accepted the cube surface, edited all the soundings out of the PFM file. I can actually use those now within GT. So every ping and beam that was deleted and said, oh, well, this is a noise or it's one of the fish traps, I cannot use in the backscatter processing. And the way we do that is we import the PFM edits. So within GT, it reads that PFM file that we've already built in DMagic and processed in Flater Mouse, and it doesn't use each of the ping and beam where there's an edit. So again, not only just having a similar structure, but we're using the supporting data objects between the applications as well. So let me just go back to the PowerPoint, to a couple of final things. Quite often people will be working on a boat and doing some work here, or they're working with their own computer in an office and they need to move projects around. You do need to be careful, and there's a few things. Remember, when we drag in the metadata, it's creating a link, and we're looking to say you don't need to drag the source data into the project. If it's sitting somewhere on your network or somewhere on a different place on your computer, it might get moved. And so in all of the applications, you need to update those links, and if you find a file that's been moved, or you know you've moved it, you can right-click on the data within the application to go and find those files. If you've moved the project and the project's on the same computer, remember that link had that it was in my file, you know, IVS files, midwater, fish traps. Now that's a link that's in the project file, so if the project file is still on my computer and I move it, that should be still okay, and you can check the validity of that. With PFM files, you need to be a little bit careful because there's other links in there you may need to update and verify. It should be mostly automatic, but good always practice to update that. The other issue that does happen is you sometimes be on a boat doing some work on one computer or a network, and then when you come back in the office to finish off, you may move all of the project and all of the source data as well, and you need to update that. Slightly different for DMagic and the other applications. One way to get around that is if when you start processing, you moved all your ungridded data within the source directory of the project in DMagic, you could move the project and it would be fine. But if they were separate, what you have to do within DMagic when you get to the new location is go and find the missing files and then update and verify the PFM. One of the things we just added to make that easier, and we've added it so far to GT and Midwater, it'll come to DMagic, is before you move that project structure, you can actually encapsulate all of the project and the data before moving it. So if you're on a job and you've got some of the data is in different places, you've got your project working on a processing machine, if you want to move that lock, stock and barrel, the whole lot, you can inflate a GT and midwater, you can go encapsulate project. But be very careful, because when you do that, that copies all of the data into the project structure. And then once you move it, it's fine. You can just open that project and all the links will be updated. But particularly midwater data, if you do that, you've got a lot of data. So that's something to be very careful of when you do that. Okay, I think that's pretty much it. Just a summary. This was really, it evolved, as I said, from really input from our clients, and as the software evolved, I hope that we have these features sometimes, and I think we let people know they're there, but hopefully the webinar gives a very brief intro of why they're there, and hopefully assists in processing when you're doing both across different applications. It was necessary to have that more organized structure. The bigger the project, we needed better indexing and metadata, because that allows for faster processing and reprocessing. One of the things, I think if you'd used Geocoder before from us, if you wanted to redo something, it was like load everything again and almost start again. Now it's gone from, sometimes from minutes and hours to sort of, seconds and minutes. So it's been a significant upgrade by having this structure, better indexing, better processing. There's less intermediate data replication because we've got it consistent across different applications. Consistent look and feel was really important across those data preparation and processing applications. And the whole idea was to really support a much better streamlined workflow when you want to do different processing within the different applications across the bathymetry, backscatter, and the midwater. So that's a quick summary. As we promised, this is a short summer webinar. I hope that was useful. And as Erin said, for particular webinar questions or inputs, to email her. But particularly, and we always like to say this, don't wait to see us if we see us at a show or somewhere. If you do really have an issue and you want to contact us, the best place is either the contact support on the web, or just email support@ivs3d.com. Okay, thanks for that, Erin. If there's any questions, or have you guys dealt with them all?
There are just a few, and Mark dealt with them. They're very focused on applying sound velocity and things like that. I don't see any other questions. We'll just give anyone who has a question, if you want to raise your hand, you can do it now. Just give it a minute. Don't see anything, so you must have been very thorough, Lindsay. If anybody has any questions afterwards, feel free to give us an email and we'll address them. This webinar should be up for download probably by tomorrow. It takes a little bit to process, and then I should be able to get it up at the end of the day today. So if you need to repeat anything, or if you have colleagues who missed it, you can download it and give it a look. Remember, if you don't have the download information, you can email me, ehefron@ivs3d.com, and if you're a client, I'll give you the password and stuff to get in and get our webinars. Oh, another thing, this is a little off topic, but we are also doing some really quick FMGT tutorials, 5 minutes or less, and they will be available on our main website. Once we start getting them up, which should be in the next day or two, we'll send out an email. But if you're using backscatter and hope to use FMGT, these will be really helpful for helping with those particular little things that you're not sure about. I think that's it. Thanks, Lindsay, for doing that. Thank you all for coming, and hopefully we'll see you again on our next webinar, which should be next month as long as we get one scheduled. All right, thank you.